On August 12, 2005, an Atlas V rocket was launched on a new mission to the Red Planet. But the destination wasn't the Martian surface, it was the Martian skies. And after 13 months, the Mars Reconnaissance Orbiter, or MRO, began scouting landing sites for future manned missions to Mars.
The Mars Reconnaissance Orbiter is a science orbiter. Is one of the most sophisticated orbiters we ever had around Mars. It's to study the geology, it's to study traces of water, and this is it's a key element of our path to the future for us to understand Mars and then for us to understand where we want to send our future missions.
It took 7 months to get the MRO to Mars and 6 months to slow it down using a technique called aerobraking.
Using the atmosphere during those 7 months period or so to slow down the spacecraft so we could put the spacecraft in the correct orbit of about 200 by 300 kilometers elliptical orbit around Mars. Aerobrake is a one-time event to save fuel. We'll save a tremendous amount of fuel that we would have taken if we did not do the aerobraking of the atmosphere.
Spectacular. This is our HD imaging lens on Mars. Every image its high-resolution camera known as HiRISE takes is another landing site experience. With a resolution the scale that the Mars exploration rovers see at the scale of 20, 30 yards away from orbit. We can see thousands, if not 10,000s of places, and then we can put them in context. So MRO is poised today to start a whole new campaign on Mars, opening our eyes to why we need to go. It is going to be the sight finder.
Getting a very high resolution allows you to look at the planet without actually having to stand there and look at it. And at this high of a resolution, for the first time, we can now see rocks of the same size that are dangerous to landing spacecraft. So now we can actually image the spot where we think we're going to go and look and see whether or not there are rocks that are big enough to hurt the landing spacecraft.
The imaging system paints 2 pictures. A wide shot to provide context that is layered onto the very high-resolution images of the planet's surface. The MRO camera is so powerful, it can see and track the rovers below.
The Mars Reconnaissance Orbiter that just arrived at Mars provides us an entirely new window on the planet. One of the first things that we did there that shows the power of robotic interaction of missions is we looked for the Spirit and the Opportunity rovers. Now that may sound like just something interesting to do, but in fact, the ability to image a rover as small as 6 feet across from space provides us not only the ability to find it and understand where it is, but it helps us build traverse maps. In other words, plan the routes that we would like the rover to take, such as Opportunity exploring the region around Victoria Crater and getting into Victoria Crater.
So we're not just going out there and say, all right, well, nice pictures. We're trying to understand what happened on our sister planet so we can try to apply and understand if any of those events could occur here on Earth.
But while machines help plan a manned mission to Mars, will humans be up to the demands of the trip? That question is being answered on the International Space Station, or ISS. The station plays a critical role in our ambitious designs for deep space. It's a laboratory in the sky, where we're learning about the science of space and the effects of long-term space travel on humans. In December of 1998, construction of the ISS began when the Space Shuttle Endeavour carried the Unity module into space. In a delicate and unprecedented maneuver, Unity was joined to a Russian module already in orbit.
Oh, this is nice. Keep her coming, and the window view is awesome. There's about 14, 15. Let me make this up. You don't like it? Son of a gun. Good job.
Unity firmly catching Ross to a great start on building the International Space Station.
And so began the most ambitious and audacious scientific project in world history. The ISS is a cooperative venture among 16 nations. It's a work in progress. When it's finished in 2010, it will consist of 10 main pressurized modules connected to a large truss system. A number of smaller modules visiting spacecraft and transports will also dock at the ISS. Powered by solar energy, the surface area of the solar panels alone will cover nearly an acre. When it's completed, the station will weigh more than 1 million pounds and will be as large as 1.5 football fields.
I think the greatest thing ISS can do is really be that permanent beachhead in space that teaches us how to go beyond. It's the Canary Islands to the Columbus trips and the Magellan trips. A 2-week shuttle mission, great as it is, and they have been, doing so many things, even mapping the whole Earth with radar as they have, still not the same as living in space 6 months or a year. And so a space station is a right step.
It will take more than 1,900 man-hours to complete the job. Because of its size, it has to be assembled in space, piece by piece. It's a painstaking process. To finish the job will take more than 100 space flights and 140 spacewalks. And outer space is not your average construction site. For example, in outer space, there's no atmosphere to temper the radiant energy of the sun. That creates a drastic difference in temperature between the sun and the shade.
In the shadow of the space station, you might be working with tools that are minus 100 or 120 degrees below 0 Fahrenheit. On the hot side, in the sun, you might come into contact with things that are 250 degrees above Fahrenheit. And above that, you'd start to melt the spacesuit glove, and that's something we like to avoid as well.
The temperature difference between these two astronauts working side by side could be as high as 350 degrees Fahrenheit. Fortunately, their spacesuits protect them from these extremes. But while the work is hard, it has its perks too.
Space station was a great place to live. It actually was fairly roomy. It was about the size of 4 school buses rammed together, but with holes cut between them, so you could float almost 200 feet from one end to the other. Floating from one place to the other is so effortless in zero gravity. So it's really fun, and I never got tired of, if I had a spare second of just doing a flip